So we're continuing on our notes. All these examples specifically have to do with complex fractions. Anyone remember what a complex fraction is from the notes last night? Yeah, it's fractions within fractions. And when we simplify them, our goal is that at the end it would just look like one normal fraction. That's our goal. Okay, so for this first example, we have x squared over 3x minus 1 divided by x squared over 3x minus 1 minus 4x over 3x minus 1. So it's a complex fraction because the whole problem is a fraction, but the problem itself is made up of 3 different fractions. Well, 3 fractions, 2 of them are the same, I guess. Minus, yes, this is a minus. So based on the video notes last night, what is the first step when you're looking at a fraction like this, a complex fraction? You look for a common denominator. So what do you see about this problem right now? Yeah, it has a common denominator for all of them, right? Okay, so you look for a common denominator, and what do you do with the common denominator? You multiply it. So we're going to say that for this complex fraction, we're multiplying by 3x minus 2 on the top of the fraction, and we're multiplying by 3x, I said minus 2, but I meant minus 1. Okay, and 3x minus 1 on the bottom of the fraction as well. Okay? And I'm able to do that because I basically am multiplying it by 1. I'm going to change what it looks like, but I'm not going to change what it equals. It's still going to represent the same thing. So when I multiply this one over here, I go ahead and change colors. That means that I'm multiplying this by 3x minus 1. And what happens with the 3x minus 1 I multiplied and the 3x minus 1 that's being divided? They cancel because we've got multiply and divide. And I have an x squared left over. So x squared is all that we have left on the top. So I multiplied the 3x minus 1. This one was divided by 3x minus 1, so they canceled. And I was left with an x squared. All right. For the bottom, I'm going to go ahead and take the 3x minus 1 and multiply it by the first fraction. And so the first fraction, I'm going to multiply by 3x minus 1. And what happens? They cancel, and what am I left with? I'm left with an x squared again. Thank you. All right. And then the last part, I multiply this by the last one. And so this is times the 3x minus 1. What happens? Cancel, and what am I left with? A 4x. And what was in between the x squared and the 4x? A minus. Okay. So now the problem that I'm dealing with is x squared divided by x squared minus 4x. And this becomes a problem now like the ones we just did. So if I just had this as like the original problem, what would you guys tell me to do with it? We'd be factoring, right? Factor and then see if anything can cancel. So is this factorable? Yes. What do we get? So we have the x squared on the top is done, right? Can't do anything with that. On the bottom, take out a GCF of x. And then x minus 4. And what do we notice? The x minus 4 is not going anywhere, right? That's a whole group. But if we look at that, we have an x squared over an x. Can those simplify? Yeah, you can take off one x from each of them. So I can take off one x, And then of the 2 up here, I can take off one of them and it will leave 1 behind. All right, so my final answer is x over x minus 4. They don't always simplify at the end like that. A lot of them don't. A lot of them would be done, but this one happened to simplify at the end. Okay, let's try another one. So for this one, we're going to have 5x over x minus 3 over x minus 4 divided by x plus 11 over x squared minus 4x minus 12 over x minus 4. So here we have a complex fraction that has a few more, well, one more piece to it. Okay, so what am I going to try to find first? The common denominator. So I can see an x all by itself. That has to be in my common denominator. I can see an x minus 4 and an x minus 4. So now I have to have 2 pieces. What do you guys notice about this? It can factor, and when you factor it, what is it? X times x minus 4, right? Okay. Okay, so based off all of those pieces, what's our common denominator? X times x minus 4. We have to have an x that's all by itself and the x minus 4. Okay, so we're going to multiply by that on top and bottom. When I take this one and multiply it by the first piece, I'm going to have times x and x minus 4. And what happens? These x's cancel, and we have an x minus 4 that's left. So now we have to multiply 5x times x minus 4. And what do you get?
5x squared minus 28.
Yep, 5x squared minus 20x. Okay. So that's the first part. For the second fraction, we're going to take it again and we're going to multiply it. So this time I'm going to multiply again by x times x minus 4. And what do you guys notice on this one? The x minus 4 cancels. And what are we left with? A 3x. And what was in front of that 3x? A minus sign. Okay. And then we've got this one times that first fraction. And so I'm going to say I'm multiplying times x, x minus 4. And what do you guys notice here? All of it cancels, the x's and the x minus 4. And so what is left behind? The x plus 11. There was no shit left behind. All right. And then we have the very last fraction. And that last fraction is still being multiplied by the x times the x minus 4. And what do you notice here? The x minus 4 and the x minus 4 cancel. And what's left over? 12x. And what was in front of the 12x? I wrote over it. It's right here. A minus. Okay. So what we have here is a little bit messier than what we had last time. What should we do with that stuff? I'm going to combine like terms. And then after that, I'm going to see if I can factor and get anything to cancel. Okay? So if we combine like terms on the top, what do we have? I have 5x squared, right? And then minus 23x. Okay. And on the bottom, negative 11x plus 11. Okay. So we have that. Can we factor anything? Yes. Take an x out on the top, and that leaves us with
5x.
okay. And on the bottom, take out a negative 11. Good. Okay. Does anything cancel? No. So if nothing cancels, that means that this was a good answer. But since we already did the work to factor it, we'll say that this is a good answer as well. Both of those answers are equally accurate. They would both be worth full credit in like a testing situation. Okay. How are your brains feeling? Brains are okay? All right. Did you tell me to chill out? All right, one more.
Oh my god.
This is why your friends giggle when they watch the videos.
Oh, you are.
All right, 4 over m squared minus 5m plus m over m minus 5 divided by 6. Yeah, I was mimicking Nadia. So what's weird about this problem? The 6. What does the 6 not have right now? It doesn't have a denominator, right? So I'm going to go ahead and put this over 1 because I have to think about common denominators for everything. And what would my common denominator be? M times m minus 5. Okay, so I'm picturing this one right here in its factored form. Okay, so I'm going to go ahead and just fix this one. That one should have been m times m minus 5. Okay, so I'm going to say that my common denominator is m times m minus 5. And m times m minus 5. Okay. All right. So if I take for the first one and I multiply this stuff by the first fraction, I'm going to say times m minus 5. And what do you notice? Everything cancels, and we get 4. All right. And then we take this part and we multiply it by this fraction. So I've got times m minus 5.
Oh my god, it's nothing.
It's not nothing. Be careful. Yeah, the m minus 5's cancel, but the m's don't because you don't have an m on the bottom. So it's a times m and a times m. So they don't cancel. So m squared. And what's in between these? A plus. Okay? And then if we look at the bottom, I'm going to multiply by m times m minus 5. And what do you notice? Nothing cancels. Okay, so we have 6m is being distributed. So I have 6m squared. Okay, and then minus 30m. Good. Okay. So this is a good final answer. And why would I say this is a final answer? I didn't even try to factor anything. Because the top doesn't factor. Does that make sense? The top doesn't factor. So if you wanted, you could have said 4 plus m squared, and you could have left the bottom as 6m times m minus 5. Or you could write it like this. Both of these are good answers.